Hello and welcome back to this video. So today we're gonna take a look at Java 21 in combination with the latest Spring Boot version. What's working and what might still have to be fixed. But without further ado, let's dive in. So this is our project here. So this is our GitHub build file. The only thing we basically need to do is to set up the JDK with Java 21, and we are using the Zulu distribution here from Azul because as the point of this video, besides the Oracle JDK, this is the only distribution that's ready for Java 21. If you are using Cradle like I am doing it, you also need to upgrade to at least Cradle version 8.3, but that's it. So taking a look at the Gradle file, what we have here. So we are using Spring Boot 3.1.4. We need a Graal builder image for our native images. So again, we are using Java 21. And as a base image for our JVM images, so if you're not using a native image, we are again using Zulu OpenJDK 21. And what's also important, you need to configure Jacopo with the latest version, this version, so otherwise you will get exceptions during compilation in combination with Java 21. Speaking of Java 21, of course, in the project structure, we need to set up our JDK. So again, this is Azul 21, which is working nicely with my Mac M1 computer here. Okay, and then right away, we should be able to start the application. So start up. Thank you for that. And we are seeing, using Java 21. So I can go and access my application. Go to localhost 1800. And then I should be able to access my application. So as we are already here, we see currently there is an open issue with Gradle and Java 21. So Gradle only has limited support for Java 21. What does it mean? I will show you this. So the issue is still open, and one of the root causes is that Kotlin, which we are using as a DSL here, is yet also not compatible with Java 21. Most of the stuff works, but there are some things that need to be taken care of. So going back, as you might have noticed, my source code compatibility is currently set to 20, not to 21, which will be possible. But I need, at least locally, to be able to switch back between my JDK 21 and 20, which is near the 21 JDK. So why is that? If we go down here, everything works. Everything works on GitHub, on Linux, but locally, if we want to deploy an image, or if we want to build a native image, we have some issues here. So for example, if I'm on JDK 21 locally and I want to create my JIP container, so my JVM container, I get an exception currently, and it says that it's problems to having to pick up the credentials. So again, this is currently only an issue locally on my Mac. On Linux, it seems to be working, but this is something you should know. There is a description. You can configure some toolchain, like it's called. So basically this means that Gradle will run with another version of the JDK, but internally still compile. However, I was not able to fix my native image with this. So this is why we should be able to switch back and forth here. But I assume that the issue will be fixed, so that everything will be working. But something important to let you know. Yeah, and if we are already here, we see this is my JIP image for building a JVM and also for building a native image. For native images, everything is safe and sound, which is very funny. And what you also see here, I have now my own image builder. So previously I was using the one from Paketo, which always needed to be upgraded. And now this is basically just using a vanilla GraalVM JDK with version 21. And then it has this very, very long Docker run task, which is basically just following the documentation from Spring. it will build a fetcher, it will decompress the fetcher, and then it will just start the native image builder internally. So we can take a short look. Oh, this will not work. So I have to, of course, switch to 20. This is why we did this. So again, and then it should work. At least in theory. Again. No, I still haven't switched the JDK, my bad. Yeah, that's the fun of early adoption. Yeah, and now you see it's extracting the fetcher, and now we are getting to the first phase of the native image. Of course, I won't leave this running through the video, so just to get you an impression. So we have our native image builder here, and this works very, very nice. So entering the first phase, and then after a couple of minutes, we will have a native image here. Of course, I will stop this. I will restart my Docker engine, and then we just take a look at the precompiled binary that's already there. So going to my README file. Then we say docker run native for ARM, and it's starting and it's working, I guess. Again. Password this time. Yeah. And here we can read data. So that's working. And what's very nice now with the latest GraalVM version, the memory reduction is really going down. So you now see we have usage 48 megabytes of RAM here for our JPA image. Previously, this was 60 to 70. So in percentage, that's a lot of reduction. And yeah, okay, that's it for this part now. So let's now take a look at Kotlin. So with Kotlin, it's very similar. However, we now need to configure in GitHub Java 20 because some plugins of Kotlin are still not compatible with Java 21. And this is at least the so-called cup plugin we are using for map struct here. If we are not using cup, it might work with Java 21. Yeah, and then we are still using version 8.1.8 from Kotlin. Other than that, nothing special here. The compatibility version, the language level is still Java 17, which doesn't matter anyway because we are not using Java language features here. And then we can right away start our application and it will work. So let's now take a look at the fun part. So why are we doing this and what benefits will Java 21 have? So one of the main benefits is Project Loom. And what is Project Loom? Project Loom is basically an alternative to spawning threads. As you might know, if we are using threads in a Java application, and especially for something like a web server application like Tomcat, it basically goes like this. You have a request will spawn a so-called platform thread, and this platform thread will go to the kernel and spawn a system thread. So for example, if you have 100 threads configured, you will have 100 threads running in your system, which can be very, very costly. And Project Loom has some kind of mitigation for that. So now instead of spawning an OS thread for every thread, we will have so-called virtual threads, and virtual threads are just part of the JVM, and it's also automatically possible to pause these threads. So this is also taken care of. At the end of the day, this means that the total number of threads you will have in your operating system is never more than 10 threads, which can be a cost reduction concerning CPU usage and other stuff, and is something that that helps you for concurrent applications. We will see this in a minute. However, this is nothing new. So this is heavily inspired of the so-called Kotlin coroutines, which were then again heavily inspired by the Go routines. One more thing is that you automatically get non-blocking calls, at least for network calls. So this is what the graphic tries to show here. So network calls so socket operations will automatically convert it to non-blocking calls. However, this is not working for file operations because the operating system needs to take care of this. There are some native applications, but most of the stuff we are doing are socket operations, and this is also something you get for free. So at the end of the day, you get a lot that reactive programming on the backend side will give you, but not for free because this imposes a lot of complexity. And here you are just getting most of the stuff for free. And how is it working? I will show you this now. So this is our application again. The difference now is that we need to upgrade to the latest milestone of Spring Boot 3.2, milestone 3, that's working. And now we really need to take care that we are using Java 21. Otherwise, this won't be working. We can right away start our application. It's not yet configured for Project Loom, so we will start our application. And now what we are going to do, we will attach a so-called profiler to our application, this one here, which can give us some insights. So go here, we go into our thread monitor. So we now see that we have 10 threads here in our operating system, and most of them are waiting because we are not doing anything. So let's do something. We will have JMeter and we will simulate 10 concurrent users. And now I will increase the screen a little bit. We will see there is something going on here. We are already getting some blocked operations. So if we take a look at the telemetries view, we see there is something going on, but we have less than 30 threads because we are only using 10 concurrent threads and the application is just working, nothing special here. So now let's increase that and let's say we will have 100 concurrent users here. We start again and then we should see, you already see the thread count has been bumped. So the upper level is 200 and we are now running about 100 threads. So if you take a look at the thread monitor, we will now see we have 100 threads that will be spawned inside our operating system. If we take a look at the thread history, we already see, most of them are just yellow, which means, they are waiting for data to come in. And we already see that they are starting to get blocked, some of them, which is the red line, which is a thing you usually don't want to have. Let's go to our telemetry fees, and we will already see that the number of blocking threads is rising. It's rising and it's rising. It's still not so much high CPU usage, but having this 100 concurrent users with a specific load, that already tells us that our application is not performing too well because the number of blocking threads which are not working, which are blocked out, are basically rising and rising again. So normally in this situation, you would impose something like reactive programming. But with Project Loom, it's not more than a single switch we need to tick. So we have to stop our application and we now have a magic switch here, which is called Spring Threads Virtual Enabled. So this tells the entire Spring Boot application to use virtual threads instead. We have to restart our application, wait for the start. And we are getting some warnings here. And we have to reattach our profiler, reattach. Okay, good stuff. Let's take a look at the threads monitor. So again, nothing going on. And now we will begin again bombarding our application with 100 threads. And now we will see a difference. So again, I'm spawning 100 concurrent users here, but we are only seeing 10 threads here, which are so-called carrier threads, or in this case, it's only 8. It can go up to 8 threads. So where are all the other threads? And this is something we can see in thread history. We are now getting a bunch of virtual threads. Guess these ones are already terminated, but you see there is a lot of virtual threads that will be spawned, paused, and at the end of the day will be processed. But the important thing is, and that's the difference, that we are now have the differentiation between carrier threads, which are part of the operating system, and virtual threads, which are part of the JVM. Our operating system will always only see 10 threads. And that's a much better resource usage. And we will see here also, we are not having the 200 upper minimum. We again only have 30 upper limit because we have basically 10 threads from under Tomcat. And we also see we have no block threads anymore. And again, think this is only by activating this. This will automatically, at least for a Tomcat application, give you all the benefits, and for the Spring Boot application. If you talk to the database, I haven't taken a look at this, you might do more, but this is already a huge benefit for nothing. And in theory, that's also working for native images, because we can, of course, also build a native image with the Spring Boot version. However, I don't have any experience how to compile, how to profile a native application, because native applications are basically machine code, and I guess some extra steps need to be taken care of. So again, that's, yeah, we have one block thread, but nothing too special. So we will detach our profiler, we will shut down all of the stuff. And then there is one more interesting thing in Spring Boot 3.2. Some of you might know that in former times we had to have a REST template, and then we had to do some things like get for object and put object and other stuff to where we need to programmatically do REST calls. And we could do this with a simple interface for a while now, but the problem is if we had the interface definition like this with get exchange and stuff like this, we needed to use the so-called web client, which introduced a lot of dependencies to reactive, to Netty. And now in combination with reactive programming getting more and more replaced by Loom, presumably the Spring people now have provided a way that we can, instead of using a web client, a REST client, which is basically based on REST template, which helps us to use it without having this extra dependency, which were called web flux. So long story short, from the next Spring Boot version on, you can just hardwire your adapter, which will do REST calls just with an annotation. And then you need a so-called adapter configuration that looks like this, which has a so-called REST client builder. And then that's it. So you don't need to programmatically do your REST calls again. You just need to define an interface like this. And yeah, no more coding with get for object and post object and all this stuff. That's just working. So that's it for today's video. Thank you so much for joining me. So you see a lot of good stuff is already working with Java 21, at least in combination with Gradle and Kotlin. There are some things that need to be figured out, but I guess they will be figured out, and we will have an alternative in the upcoming weeks. And that's it for now. Have a nice day, and I hope to see you in the next video. Bye.